Hi, this is Miss Wiles, and in this video we'll be talking about circles. Circles, 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 and the equations of those circles. The equations of those circles, we've talked about standard far. On a couple of other videos, you've seen me talking about standard form, where when you know the center, you need to know the center of the circle and the radius of the circle. And if you know the center of the circle, like 0, 0, and the radius of the circle, like 10, then you can tell what the equation is. With the center at 0, 0 and radius of 10, the equation of that circle is x squared plus y squared equals 100. Or if you start with the equation, you can tell from this equation that the center is 0, 0 and the radius is 10, because the radius is the square root of the r squared that you have here. And then we talked about circles that the standard equation looks more complicated. It looks something like x plus 3 squared plus y minus 4 squared equals 36. And from this equation, we could tell that the center is negative 3, 4, because it's the opposite of this. The x coordinate of the center is the opposite of the plus 3. And the y coordinate of the center is the opposite of the negative 4 or minus 4. And the radius is the square root of 36, which is 6. So we can tell all those things from standard form. Well, there's another form of the equation of a circle that's not as helpful. In fact, it's kind of ugly. And we don't call it the ugly form of the ugly equation of a circle. We call it the general equation of a circle. The general equation of a circle will look more like this. I'm going to pause here while I think of one. So I'm back because I thought of x squared plus 6x plus y squared minus 8y equals 11. In its general form, this equation doesn't tell us what the center is. It doesn't tell us what the radius is. It doesn't tell us anything at all, except for we can look at it and say, okay, I've got x squareds and x's and y squareds. I've got x squareds and y squareds, so I've got a circle. That's all it tells us just by looking at it. What you don't know when you're watching this video for the first time is probably this. This equation is exactly the same as that equation. It's exactly the same as that equation, you just don't know it. Because if I take this x plus 3 squared, in fact, let's expand this standard form of the equation. So if I take the x plus 3 squared and I do binomial multiplication, which I will not do step by step in this video because that's another video. That's something that you should know how to do and be able to do by the time you mess with circles. X plus 3 squared is x squared plus 6x plus 9. That's using FOIL or the double distributive property or whatever you want to call it to get that. Y minus 4 squared is y squared minus 8y plus 16. And we still have that equal to 36. All we've done in this first step is expanded this. Now, would we ever really expand a standard form of a circle, a standard equation of a circle? No, because the standard equation tells us the things that we want to know. The standard equation tells us what the center is, and it tells us what the radius is, and that's what we want to know. But when we have a general equation, we need to be able to get back to the standard equation so that we can get it. So I wanted to show you where this comes from, because then I would look across to see if there are any like terms. There are no other x squareds. There are no other 6x's. But here's a 9 and a 16. That would be a plus 25, and I'm just going to put it on the end here because that's where I like to put my numbers. And then a plus y squared and a minus 8y. And that right now still equals 36. But if I felt like it and wanted to put this in general form, I could subtract 25 from both sides of this equation, and I get x squared plus 6x plus y squared minus 8y, and that equals 11. Now, I like to call this the ugly form, but all the math textbooks call it the general form. It is ugly. It doesn't tell us what we want to know. So I'm going to show you in this video how to start with an ugly general form of a circle equation and then change it into the standard form of the equation so that you can determine what the center and the radius of the circle are. So this paper is gone now, and now we're going to do a couple of examples of some general forms of circle equations, or the general equation of a circle, and we're going to change it to the standard form of the equation so that we can tell what the radius and the center are. So we'll start out pretty simple. Let's say we have x squared plus y squared minus 36 equals 0. Well, that looks almost like I want it to look, but I have to remember what the standard form looks like. And the standard form has the x squared and the y squared on the left-hand side, or on one side, and then the number all by itself on the other. So to make it look like I want it to look, I need to add 36 to both sides, and now I have x squared plus y squared equals 36. And from here, I can tell what the center is. The center is 0, 0, and the radius is the square root of 36, which is 6. So I can tell just by moving something what it is. Other times, I might have an equation like this. X squared plus y squared minus 7y equals 10. This is a very ugly equation because it has this y in it. For a circle, I really just want to have this, I want it to look like the old standard form. That's what I want it to look like. So I've got to work on this to make it look like that. Now, if I take the x's by themselves, I'm okay with x squared. X squared is fine. I don't have to do anything to change x squared. X squared is fine. But I need to make this y squared minus 7y look like y minus or plus something squared. It's called completing the square. I have a y squared minus 7y, and I need to find out what number goes here so that I can complete that square. What number would go there to complete that square? And the way that I do that is I have to remember or think about, okay, I'm going to bring this other one back. Here we come. It's coming back. When we had x squared plus 6x plus 9, think about this 9 and this 6. Look at that 3. 3 squared is 9. 2 times 3 is 6. Okay, now think about that. Now think about this one. We've got a y minus 4. Negative 4 squared is positive 16. Negative 4 times 2 is minus 8. We complete the square by figuring out what number would have to go in that spot. If I've got a 7 here, 7 is not the best one to use because we're going to have a fraction. I know how much y'all hate fractions, but we're going to start there anyway. Okay? I need to take half of that 7. Divide that 7 by 2 and square it. I'm going to add it. I'm going to add whatever this number is. We'll call it B. Whatever this number is, I can keep it negative. It's not going to matter because I'm going to square it anyway. Whatever this number is, divide it by 2 and square it. You get to use your calculators all you want, so you can do that. Remember, the x squared is okay. The y squared minus 7y plus negative 7 over 2 squared. I am adding, if I add negative 7 over 2 squared to this side of the equation, I have to do that on this side of the equation too, or the equation is no longer in balance. It's not balanced. So now I've got y squared minus 7y. The negative 7 over 2 squared is 49 over 4. It's 49 over 4. And then on this side of the equation, I have 10 plus 49 over 4. And that's going to give me like 89 over 4. Now I can make this thing look like I wanted it to look. I can make it look like the standard form because I've done what's called completing the square. The x squared stays just like it is. It's just x squared. I'm pretty happy with that because there were no x's in there bothering it. The y squared minus 7y plus 49 over 4 becomes y minus 7 over 2 squared. Y minus 7 over 2 squared. Now, as soon as you find out whatever you have here that you have to square to find out what you have to add to both sides, it's going to show up. It's going to show up again here. And then on this side, this stays 89 over 4. Once I have the equation in this form, then I know that my center is 0 for the x value, 7 over 2 for the y value, and my radius is the square root of 89 over 4. Which on a multiple choice test, you might not see square root of 89 over 4. You would probably see the square root of 89 over 2. So in the magic of the pause button, I've come up with another problem here. And you may look back at this one after you look at this one, because I think I've come up with some numbers on this next problem. We'll call this example 2A. I don't know why, just because I feel like using 2A. So in this example, we've got the ugly form of an equation for a circle, also known as the general form. But we've got x squared and y squared. We've got an x, we've got an y, and we've got a number. So we know we need to change this. We need to do what's called completing the square. And I know it sounds odd to be completing the squares when we're trying to complete the circle, but that's what it is. So we're going to complete the square with the x's. Now the x's are x squared minus 6x. So we group those together because x's and y's don't like to hang out. Then we take the y squared and the 2y and we're going to group it together. So we've got about 5 different problems going on in here. So we have to take it one step at a time, focus on one part at a time. So first we focus on the x portion of the problem, and we take this negative 6 and divide it by 2. That's going to give us 3, so we're going to add 3 squared. We're going to add 3 squared to this side. We still have a plus in here with the y squared. Then we're going to, now let me break out here and show you where you got that 3 squared from. You had 6 that came from here. You've got that 6 divided by 2, and you're going to square it. That's where the 3 squared came from. Over here, with this 2y, we're going to do the same thing with it. We're going to take that 2, and we're going to divide it by 2 and square it. So here we're going to have a 1 squared. Now I'm only writing them like that because we have to remember that if we're going to add a 9, if we're going to add a 3 squared here, and if we're going to add a 1 squared here, then we have to add a 3 squared and a 1 squared on the other side of the equation too, or it's not balanced anymore. So I have x squared minus 6x plus 9, and you could jump straight from here to here if you know 6 divided by 2 is 3 and square it, and I've got 9. Y squared plus 2y plus 1. And on this side of the equation, I've got 38 plus 9 plus 1. Now you can take as many shortcuts as you want to. I'm showing you where every number comes from so that you don't have to figure out where the numbers are coming from. On this side of the equation, I've got x squared minus 6x plus 9. Well, that gives me, when I factor it so that it looks like that standard form of the equation, I'm going to have x minus 3 squared. Now that 3 came from the same place here.
Where it come from?
It came from half of 6.
Got it.
Half of 6. Because 3 squared is 9 and 3 times 2 is 6. It's a minus because that's a minus. Then we have the plus. We have y plus 1 squared. Why? Because 1 squared is 1 and 1 times 2 is 2. All of that coming together, I did not find the number that I wanted over here. 3948. I wanted it to be a perfect square, but it's not. But that's okay, because not every circle has a perfect square for its radius squared. The center of this circle is 3, negative 1, and the radius of this circle is the square root of 48, which on another video in rationalizing these things, let's break this down. 48 has a perfect square that is a factor, and that perfect square is 16. 16 times 3 is 48, so the square root of 16 times the square root of 3, and your answer will be given as the square root of 4. That is a lie. The square root of 16 is 4, and the square root of 3. So your radius is 4 square root of 3, and your center is 3, negative 1. And that's a couple of good examples, one not so bad and the other one a little bit different. But we're gonna leave this video like this. And that's all I have to say about that for now. Thanks for watching.